So hey guys, it's our day 6 of doing Leetcode daily until I get a job. So let's start with the questions today. We are doing these 4 questions today from binary search section, and we'll try to do them within 30 minutes. And if it's take more than that, let it be. But we will try to do it before that. So first question is binary search, and it's simple, I guess, that we are given an integer array sorted and a target. We need to find it. If it exists in this, we will need to return the index. Otherwise, we will return -1. So let's go with it. Low is 0, high is, we know about this, right? Nums dot size -1, and y low is less or equal to high. We'll go inside it and we'll declare a mid, and low plus high minus low by 2. Now we will do if nums mid equals to the target, then return mid, and else if nums mid less than target, low goes to mid +1, else high goes to mid -1, return -1. That's all for it. Yeah, we got this. Okay, so this is the second question, which is search a 2D matrix. We are given a m by n integer matrix with the following two properties. Each row is sorted and in non-decreasing order. So these rows are sorted. Okay, and the first integer of each row is greater than the last integer of previous row. Means the columns are also sorted, we can say, right? So it's basically like these rows are sorted, and this element will always be greater than this element. Means first element of any row is greater than the last element of any row if it exists. Okay, so obviously firstly we need to find the row where this target exists, and which we can find out by, like, these are also sorted. At least these first elements are sorted, right? So by applying the binary search, we can find out in which range this target exists. Like 3 exists between 1 and 10. So 1 and 10 means this is the row we need to consider, and then we get the row number. We can apply the binary search in that row because that row is sorted. Okay, so firstly we need to apply the binary search from top to bottom in the first column. Okay, in the first column, so top is 0, bottom is matrix dot size -1. Okay, so while top is less or equal to bottom, what we can do is that int mid is top plus bottom minus top by 2, and if matrix mid, this is the row, column is 0, matrix mid row is less than target, and matrix mid and not 0, actually, yeah, 0 it is, first element, and the second element is, second will be, this is the row, right? The row in the first column of it, and matrix, this row, we go to every, like, row one by one, right? Firstly we are going to this row, obviously, if this exists between this and this, so matrix mid and the last element of its matrix 0 dot size, matrix mid dot size, that's the same thing. mid dot size -1. What does this signify is that matrix mid, any of it we can take, it's just the same thing, so we can also take 0 is greater or equal to greater than the target. If it is this is the thing, then we will just break. We got the row, that is the top plus bottom minus top by 2. Else if matrix mid 0 is greater than the target. If matrix mid is 0, first element is greater than the target, and it doesn't exist between this let's see, if our target is larger than 10 and it doesn't exist between these two elements, then it must be in the next one. So we will increase the if the target is greater, no, the target is less, so target must be on upper side, so we will see the bottom to be mid -1. Okay, and else top to be mid +1. Okay, so in this way we get the row number, and that will be top plus bottom minus top by 2. We got the row. Now in this row we will apply the binary search. I is matrix dot size, matrix row dot size. Okay, 0 dot size, number of columns in it, 0 dot size -1. Okay, we have the row, sorry, low and high here. Okay, now we will apply the binary search here, that while low is less or equal to high, what we can do is, while this low into mid is low plus high minus low by 2. Okay, and we will check on this mid, that if matrix row mid equal to the target, return true. Else if matrix row mid is greater than target, if it is greater than target, then target is less, it is more, it needs to be less, so high is equal to mid -1, else low equals to mid +1. And we will just return false. We should do the thing. Let's try submitting it. Okay, we have a thing here that matrix row is equal to the target, right? Return true matrix mid row. Left plus right by 2. Low is less or equal to high. Row mid O plus high -2. Okay. Top plus bottom. Here it is the B, overflow is happening. So high is this. What's our mid? If we see out mid for this okay, output is 0. Yeah, it's 0, fine. And row, what's the row? See the row of it. Row is 1 and it is false. Okay, it is false. Row should not be 1. Top plus bottom minus top by 2. It comes here. Top and bottom both are 0, right? Matrix dot size 0. It will go for ones, and the mid is 0, is less than the target and greater than the target. There must be an equal sign also, right? Greater, less, or in between. If it's even equal to target, and if it's also equal to target, what happens now? Okay, equal should be later than this. Then what will happen? Still overflowing here, and 1 is returning as from there. Okay, matrix mid means 0. What's the value of mid here? See out mid null. So if 0, mid is 0. Okay, so matrix 0 0 1 is less or equal to target, and matrix mid 0, matrix 0 dot size 1 minus 1, matrix 0 0 is greater or equal to target 1. So is it true, right? True. If it break here, and what's the value of mid here? So it doesn't even go inside this. Matrix 0 0, matrix 0 0 is 1. So matrix 0 dot size see, it is not even going inside this if condition. So 0, and this is the first element of this row, and this is the last element of that row. What happens now is that it is returning 1 1. It is less or equal to target. Less or equal to target. It should return true, right? It is greater or equal to target, right? What? Oh, it's returning 1 and 0. This is true, 1, but this is 0. Matrix mid. Why is this happening, man? This should not happening. Should not be happening. Oh fuck. Control C. Right. Okay. So it is 1. Okay. And now this. It is equal to 1. It is equal less or equal to target, so that's why it's returning 1. And matrix mid, this exact same thing here is greater or equal to target. This is returning 0, but this should return 1 because it is equal to target. Oh man, what's wrong with doing? Hmm. Why is it returning 0? Zero zero one 0 0 1 0. How can this be happening? Okay, let's do the next question. We will look at it at the last. So Coco eating bananas. Coco loves sweet banana. There and pile of banana. I pile has piled five bananas, and the guard has gone and come back in HS. Coco can decide to banana hour eating speed of K. She is eating K bananas per hour. Each hour she chooses some pile and eat K bananas from that pile. If the pile has less than K bananas, she eat all of them instead and will not eat any more bananas during this hour. Mummy. Coco likes to eat slowly but still wants to finish eating all bananas. Coco likes to eat bananas slowly but still wants to finish eating all the bananas before the guards return. Okay, the return the minimum integer case is that she can eat all the bananas within 8 hours. Uh, so, so we have to find a value with that is the speed with which the Coco is eating those bananas per hour. Okay, she has 8 hours. With what minimum speed she should start that she can eat all the bananas? Okay, minimum value basically. But if we talk about if we forget this condition, minimum integer, if we just find any integer key, then what maximum value can it have? It can have the maximum value of this, right? For this answer, that if we do it 11, it will require minimum 4 hours, right? Before 4 hours, it cannot do that. Means the greatest element in that pile. If yeah, yeah, the greatest element in that pile. So and the maximum value can be this, and the minimum value can be this only, right? But can she finish this pile with this value? 3 6. So 1 hour, 2 hour, 3 hour, and 4. It will require 10 hours, but we have only 8. So 3 will not work. 11 is too much. So somewhat in between them we will try to do, right? So we can run the binary search on this only, that we can take the minimum value to be this and maximum value to be this. So yeah, So in our binary search, low is 0, high is max element of files dot begin to files dot end. Okay, we have this, and let's say the answer usually is -1, and while low is less or equal to high, we will go and mid is low plus high by 2 by 2, and what's the constraint? 10 to the power 9 is there, so while psi is also 10 to the power 9. So let's check long. What is the number of hours it will take to eat with mid as the eating speed? So let's take HRS hours, and let's say we have a function helper. We will provide files in it and mid in that. We get a value from there that this is the number of hours it will take to eat with this speed, which is mid. Okay, and if this speed mid, if this number of hours are less or equal to the target or the h value, then it's fine. Then our answer will be updated as mid, right? And the high will be coming to mid -1, else low is equal to mid +1, and we return answer. So what happened here is we find this hours value. If this hours value is less or equal to mid, if this hours is we have to put hours here. Hours value is less or equal to this maximum limit of hours for which the guard is gone, less than that, then it's fine that this is a valid speed, and we will update this answer. Okay, why will we update this answer is because that it is a speed. So if we get a speed between low and high mid, the next time anyhow if we get such a speed which is valid, that the number of hours is less than the target, then obviously we will try to find a lesser value than that. That's why we are doing this high is equal to mid -1. So initially let's say 0 is the way here and 11 is the high value, 0 is the low value. Okay, mid is what? 11 by 2, 5. So we will start with 5. Okay, when we have the speed of 5, we find the number of hours, and for 5 the number of hours can be what? For the 5 the number of hours can be 1 plus 2 3 plus 2 4 5 and plus 3 8. 8 are the number of hours. It is equal or less or equal than that. Okay, 8 is possible. Answer, we will update the answer as 8, and we will put the high is mid -1, means 5 minus 1. You're thinking about that, right? So now we have a speed lower than that. So we will now move from this side, from higher side to lower side. We will have a small range, but our high value will be less now. We have an answer, valid answer. So now our mid value will be 2. Okay, because the high is 4 and low is still 0. So we'll have a mid value 2. So with the speed of 2, what can it do? 2 into 4 and 3 hours for this, 5 and 8, 13. So it must be greater than 8. Okay, then we will push the low to mid +1 means low will be 3 now, high is 4 now. 7 by 2, 3 will be the new mid. So with the mid as 3, how much time it will take? 1 2 3 4 5 6 and 4 10 hours. So it's still there. So we will do mid +1. So low is 4, high is 4. Now the mid is also 4 with the speed of 4. What can it do? Let's say, so we have to take the minimum value of mid. Okay, if we have any value of mid which is valid, we will go only from only on the low side, because we want the minimum value of mid. Okay, so with the 4 value, 1 hour here, 2 hour here, how much time it is? 3, 2 hours here, 5, and 3 hours here, 8 hours. Again the answer is 8, but the value is now 4. Okay, so this will be the answer here. That's how it's done. So we just need to complete this helper function now, which will return us long, and helper is the name, this is the vector, and int x, let's say, is the speed we are passed on. So long answer is equal to 0. Okay, so for int I 0, so I files dot size I plus plus. Okay, so int hours to 8, int temporary मान लेते हैं, temporary value will be ceiling of, डिवीजन करेंगे ना with what, piles I upon में speed, piles I upon में the speed with which, any x, but we will do this because we are obviously getting it. So we'll get a value here, so we will add it to the answer plus temp, and we will just return the answer. See, it's not login. Yeah, okay, we can run it now to check if it works fine. Okay, yeah, it's fine. Let's try submitting it. Infinity is outside the range of 9/6. Okay. Seal of file size. If we do it long, will it work? So what can be the issue here? Zeros to piles, sort size, temp, ceiling value of CEIL of pile size over of the speed, right, which we passed from there. Is what it's returning. Helper, right? Returning piles and mid, and we initialize it with 0. Answer is 0. So this should be what could be the issue here? What's it, the range of it? How the hell is it possible? It's upon me too. Hmm. It's a tricky question. Today 13 minutes is already done. We are on the third question and now we have solved complete question. Only one question. Oh, it's. Are we missing anything here? So, we are doing this. Okay, this is returning that infinity is out of the range, right? So how is infinity out of the range? I think 8 hours. And right is mid, and we pass on the value of this mid, and that the mid is here. If the mid is here, here is the mid, and we will do what? Mm, 0 and in subtotal and pile return subtotal was prime minus 1 by m. Subtotal and what can be the issue with this question now? Oh man, holy shit. I converted to double. Yeah, that's fine. But still, hmm. Hour spent plus is by 2, and hour spent is 0, and we will go to every pile, and in every pile, hour spent will be. Uh, let's do one thing. Let's do one thing. Instead of this, let's take it as int only. Instead of a ceiling, let's piles over x plus if piles I percentage x, if this value is 0, then 0 else 1 plus material. What now? It should be fine, I guess. Yeah, man, again. Uh, why is it doing this? And k and can't it be int also? No. Division by 0, 0. Line 6, Oh, where is it divided? Where are we dividing it by 0, man? Where are we dividing it by 0? I don't understand that. How can x be 0? How can x be 0? Okay, it's gonna take time. So see, let's start from the beginning now. So we have the low as 0 and high. Okay, high as the maximum element of the pile. Fine, we're good here. Okay, now what will happen is that is this right that but I think that's fine if we have the max element as the largest element of this pile. I don't think there's any problem with this, right? Is there? See, if we have this low as 0, oh, I guess what will happen when we have this low as 0? It should have a speed of minimum 1, right? It is given. It's if it's not, then and that's it's obvious that it should have at least a speed of 1. So if we take it as 1, then run. Okay. Well, yeah. Okay, it had a minimum speed of 1 at least when we were taking 0, so that's where the thing was happening. Fine. Okay, find the minimum in the rotated sorted array. So let's have pretty popular questions that we are given an array which is sorted but it's rotated. Okay, that 0, 1, 2, then 4, 5, 6, 7. So this is sorted and this part is sorted, but they are rotated. So we need to find that it is rotated 4 times, 7 times rotated, then it will be same array. Okay, we need to find a minimum element in the sorted array. So okay, so first thing is if to find it, let's do the simple binary search only. We can do it. How can we can do it is that if we take this array, let's say, okay, this is the array. Left is this. This is the left. This is the right. Okay. Now we will start. Mid is what? Is 5. So 2. This is the mid at the initial stage. So if the mid is it, uh, we will check, is the mid element higher than bigger than the right or not. If it is bigger than right, means what does it mean that the mid element is bigger than the right in a sorted array? It means that the starting point of the sorted array is right of this mid, that's for sure. Okay, the starting point of this is mid, this array is this side of the mid if the right side element is smaller than the mid element, because right side should be bigger than the mid element, right? So we will push the right as the mid. So right will be here. Oh wait, no, if mid is bigger, Then left will be here, left will be here, sorry, left will be here, and right is right here. So we have now 2 and 4, 3. This will be the target element. Now we will see if this is smaller than right or not. Is it smaller than right? Yes, it is smaller than right. Then yes, we have it. But still, if it's smaller than right, then right will be moved this side. Maybe in this range we have something. We are not sure now. So right will be here. Okay. Now left is 2, right is 3. So it will be 2 only. So left is mid is here again, and again right is smaller, mid is bigger, so left will move this side. So left is here, right is here, so on the same. So this breaks out, and we have the solution now. Okay, we can write. So here we can write that and mid is low plus high by 2, and if nums of this mid is smaller or equal to nums of high, then it's all right, like if mid is smaller, high right high one is bigger, then this side is fine, this side is working fine. So smallest will be on this side, so uh, high will be equal to mid now, and else low is equal to mid plus 1, right? Right on. Where will it stop? It will stop at the low or the right, right? Limits of low. Yeah. Now what happened? Okay, now is it not left? What happened, man? Yeah, this is done. So this question remains now. This is the 21st line. Why the fuck this was happening? We still couldn't figure this out. So we'll try this once again. Try to go through all of this. Okay, let's see the question again. So you're given a m by n matrix, and your every row is sorted. Okay, and every element of the first row is bigger than the last element of the previous row. Okay, got it. What else after it is that mm, okay, we first are doing this matrix thing, this binary search thing from top to bottom to find which row is the one we need to go in. Okay, n is the number of rows, m is the number of rows, n is the number of columns. Okay, right is this. Fine. Row size counts as row 0 counts as columns minus 1. Okay, minus 1. While row is row is if current is this, if current is target. Wait. We can apply another methods also here. See, we are having these rows sorted, right? So what we can think of is that we can take the rows one by one. We get in the first row, okay? In the first row, in the first column, okay? In the first column, let's say in the last column. I'm the last column of the first row, and I'm checking it. If it is equal to target, then return true. And if target is greater than this value, then we will go to next row. And if it is not, then we will call minus minus. But the thing is that it is a on search, not of log n, because it will iterate through the whole row that way. Okay, I will iterate through the whole row. So no, this method cannot be employed here. So then what else? Okay, firstly we need to find the row here. Matrix. With this matrix, matrix dot length array I is matrix I 0. Okay, we are taking the first element of each row. Let's say we take the first element of each row and form an array with it. And in that array we apply the binary search. If the value doesn't happen to be coming, then we can return on any of the start or end. Okay, we will know that in which row it is the element there. If we get that row, for that row we can apply the binary search again. We are doing exactly that. No, we are not doing exactly that, but for that also we need an extra space. So not that also. If we have binary high low, okay, and low high, okay, low is less than high, low is less than high, mid calls -1, last column is equal to target and return true. And if it is greater than the target, then yeah, I maybe we are doing it the wrong way, like the finding the row thing. Let's try doing this way, that okay, remove this all and have a variable row -1. Okay, remove it. And in that while loop, let's do one thing, that if matrix row is fixed mid, and let's say last column we take, last column is matrix 0 dot size -1, last element of that row. If it is equal to target, we can return it right there, return true. And if it is not, else if this element is greater than that, less than the target, if it is less than the target, then low will be mid +1. Okay, we will go to the next row. Else if it is greater than target, if this value is greater than target, means this value is greater than target, then it must be in this row only. So row will be equal to mid. Okay, we are in this row only, and high is mid -1, right? We are updating the row every time. Maybe it's we have to go more up, but there is nothing more up and then that, then the loop bit break. And if we didn't find the row it should be -1, then return false. Okay, else we are on the right track. Rest is all fine, I guess. Low. Okay, not low. It should be top, bottom. Yeah, I did. Let's try submitting it. Okay, this worked, and we all know why it worked. But I can still figure out why was the last method not working and what was that error where it was. Maybe I will try to fix that or come up with what the problem was there in that code. Till then, I guess we're done with all the questions today. 100%. Three questions were 100%. So yeah, pretty good with it. We will do the remaining 3 questions tomorrow for this binary search. Okay, so that's it for today. The biggest video up to now, 51. Okay, yeah, that's all, guys. Bye for today. We'll meet tomorrow.